It is definitely coming towards us. NASA has quite recently distributed stressing new information about the space rock Apis, and researchers are warning we still don't know everything about this 370-meter-wide space rock. We still can't preclude the probability that Apis will go by the Earth. This much is sure. If out of the blue it influences, nothing will ever be the same again. We are facing an event of the 100 years. In 2029, the space rock Apis will go in close vicinity to 31,000 kilometers of Earth, closer than many satellites in Earth's orbit. Named after the Egyptian god of bedlam and obliteration, Apis lives up to the name unequivocally. What will occur if this infinite stone in fact strikes the Earth one day? Space rocks of this size could cause huge regional pulverization. An impact would deliver the energy of a few thousand atomic bombs. The blast alone could totally obliterate cities and crush enormous regions of land. The residue and flotsam and jetsam raised by the impact would obscure the sky for weeks and influence the environment around the world. Depending on the location, huge tidal waves, firestorms, or strong seismic tremors would be further prompt results that could bring our human civilization very close to annihilation. Apis is a reminder for humankind. We should further develop space rock monitoring and defenses to shield our species from such disasters. To this end, NASA has sent off the OSIRIS Summit mission. A test is set to gather material from Apis and, in this way, give us options for defense. OSIRIS against Apis. Who will win the challenge? Despite the fact that our researchers like to guarantee that they are clear-headed and practical, we find magic and religion wherever in space. Our planets are named after divine beings and goddesses, and even the space rocks are profound. In the case of the space rock Apis, NASA sent a test called OSIRIS to save our reality. It seems like something out of a science fiction comic, but it's true. In ancient Egypt, Osiris was the god of order and resurrection and, consequently, the direct opposite of Apis. Anyway, Osiris didn't control in heaven, but in the underworld, which was so critical to the Egyptians. As the god of resurrection, Osiris guided lost spirits into the light and to a good return to earth. Apis, on the other hand, was the one who tried to plunge the forlorn creatures into tumult as a noxious snake. He deceptively trapped the departed to blame. A space rock for mischief would absolutely be going too far, but this hunk of rock also messes with us in a manner. Apis presents a riddle for analysts. Its direction is difficult to determine with conviction, and thus the space rock caused a lot of turmoil on its most memorable appearance, previously seen in June 2004. The space rock Apis precipitously set off a Class 4 alarm on the Turin scale. This is a stressing value that warns us of a real risk of impact. Computations showed an impact probability of 2.7% in 2029, which is an incredibly high value for a near-Earth space rock. Researchers and state-run governments worldwide were frightened. An impact of Apis would deliver the energy of 65,000 Hiroshima bombs. Wherever it would hit, annihilation and suffering would be the result. New orbit investigations showed that Apis would go by the Earth at a distance of around 31,000 kilometers in 2029. The all-clear could be given, but then the keyhole situation arose. If Apis 2029 goes through a tiny region in space, it would change its orbit so that it would really hit Earth in 2036. We must be ready. In 2016, NASA sent the OSIRIS-REx test to the close Earth space rock Bennu. NASA chose to proceed with the successful mission when OSIRIS-REx had successfully delivered rock samples gathered on Bennu. The test altered its direction and is now heading for Apis. The awe-inspiring gathering of Apis and Osiris in space is planned for the year 2029. As in the first mission, the roughly 2-meter-tall OSIRIS test will look at the space rock, gather samples from its surface, store them securely in a special compartment, and then return to Earth. The stone is expected in the early 2030s. With the help of the samples, researchers will be able to study the composition of Apis and gain a better understanding of the potential dangers posed by near-Earth space rocks. In addition, the results could serve to develop viable planetary defense systems to redirect Apis from its impact path or tow it away one day. We need facts about its composition, mass, and thickness to better guard against tumult and obliteration. Dart meets Dimorphos. It was a momentous first in the history of humankind. On September 26, 2022, NASA's DART mission hit its objective, the small space rock moon Dimorphos, part of the double space rock system Didymos and Dimorphos. This brings us back to the realm of mystery in Greek mythology. Dimorphos was a term for twin and appeared around the legend of Castor and Pollux, who as indivisible siblings together formed the constellation Gemini. Didymos means double, and in this case refers to the unusual double space rock system, which is situated around 11 million kilometers from Earth. Kill them from Earth with DART. We have a less mysterious, however more specialized, legend at the beginning. The instrument of the twofold space rock redirection test was arranged straightforwardly at the more modest Diros as part of an investigation to push the rock out of its circle. The legend, one poking the space rock an entire 160 m off its old way, is crazy. But in a crisis, such little changes could save our lives and the planet. The previous we push in space rock, the less power is required. The DART mission was the first endeavor to redirect a space rock from its way by human intercession and a total victory. The way to this grandiose duel was an innovative peak of power. DART hammered straightforwardly into Diros at around 22,000 kilometers per hour. The objective was never to annihilate the space rock. In fact, obliterating a space rock would be the least reasonable form of protection in a crisis. If we try to explode a space rock, bits of trash could turn into an endless risk. The DART test was completely outfitted with an independent navigation system. It guided autonomously towards Diros in the last hours and minutes before impact. DART's cameras were active until not long from now, before their courageous end. After the impact, a small satellite called LIIA Solid Cube took over the documentation of the impact at short proximity. In 2026, Hera will show up at the effect site. The test of the ESA will analyze the consequences of the impact of the DART test with Diros in more detail. It's wanted to take exact visual documentation of the effect site and to observe the impacts of the adjustment of the orbit over an extensive stretch of time. Top 3 most dangerous space rocks. If we investigate the truth, it's startling. The Earth is continually threatened by a huge number of objects from space, and most of the time, we are uninformed about this peril. The fact that a space rock can crash from the sky at any time, bringing suffering and obliteration, is demonstrated by the Chelyabinsk disaster in 2013, which harmed large numbers of homes and injured individuals. Smaller space rocks can fall through our satellite observation at any time and move toward inconspicuous larger space rocks and comets, which are seen continuously by telescopes, for example, Pan-STARRS in Hawaii. We currently know of more than 100 objects that fly close to Earth and could hypothetically be on an impact course with it. The risk of a significant impact is currently thought to be low. All things considered, we should be careful. One of the most popular techniques for assessing these dangers is the Torino scale, which combines the likelihood of an effect and the energy released to precisely survey the peril presented by an object. Objects with a higher score are more risky and require closer observation. One of the most dangerous known space rocks on the Torino scale is Bennu. Bennu has a size of around 490 m and a mass of 67 million tons. It was found in 1999. If it somehow happened to impact, it could discharge the energy of 1.4 billion tons of dynamite, which is vastly more than the largest nuclear bomb ever tested. The likelihood of an impact is currently 0.037% in the year 2182. If the space rock changes its orbit due to a vast event, it might still become a risk. 2023 TL4 is a space rock that was newly discovered in 2023. Like Bennu, it was quickly designated potentially hazardous, with a size of 0.33 kilometers and a mass of 43 million tons. It could release the energy of 7.5 billion tons of dynamite in an impact. However, the likelihood of an impact is currently low, although there will be a risky approach in 2119. The crash likelihood is currently only 0.55%. These objects are closely monitored by NASA and ESA to analyze potential changes in their orbit and develop countermeasures early. Currently, the most dangerous space rock on the list is 1950 Da, which was first found in 1950, then disappeared and returned 50 years later on the screens of planetary defense specialists. With a size of 1.3 kilometers and a mass of 71 million tons, this space rock could release the energy of 75 billion tons of dynamite in an impact. The destructive power would therefore be far greater than that of 2023 TL4 and Bennu. The likelihood of 1950 DA impacting Earth in the year 2880 is currently 0.029%. All of these situations seem far away to us, and we can calm ourselves into a misguided sense that everything is okay. However, one upsetting reality remains. New space rocks can appear repeatedly, and a previously unknown object can appear at any time that is on an impact course. Researchers currently expect that they would be able to identify a larger space rock years before impact. This is because space rocks can't race toward Earth in an orderly fashion. Their directions usually make them slowly approach Earth. Space rocks generally move in elliptical circles around the Sun due to gravitational forces, but these orbits can be affected by the gravity of other celestial bodies, and encounters with other planets or objects can also change the orbits of vast bodies. As a result, space rocks that were initially thought to be harmless suddenly become a boundless risk. Most space rocks are bound in the asteroid belt between Mars and Jupiter. Sometimes, they are hurled out of this belt and can then come dangerously close to Earth. Did you know that the Earth is hit pretty much every year by smaller particles that burn up in the planet's atmosphere, like meteorites? Smaller space rocks, with a size of under 10 m, stir things up around the Earth's surface a few times each year. These smaller impacts typically don't cause significant harm, but they do remind us, in an unpleasant way, that the Earth is constantly threatened by large objects. Some scientists speculate that Jupiter can occasionally direct a wave of space rocks toward Earth through gravitational effects. This has happened repeatedly in the history of the Earth, and we don't know when the next such assault will come.